Hello, in this video I'm going to explain to you how we can calculate something called cumulative probability in the binomial distribution. So again, we're talking about binomial distributions. These are situations in which things can be one way or the other. We know the probability, and very important, the events are independent. So when we know how to calculate the probability that if I flip a coin 20 times, that I get that result a set number of times, like 11 times, that I get heads 11 times, 13 times, 14 times, etc. I can calculate it, I know how to calculate it for exactly 3 times, for exactly 11 times, etc. What's important though is that most of the times I'm going to be okay if I'm going to need 11 times heads, but if I get 12, 13, 14, that's also fine. So cumulative probability deals with that type of situation where I'm going to be dealing with multiple valid results. Normally situations where more than 3 times is okay, more than 8 times, less than 7 times, etc. So in our previous example, I don't know if you remember, there was 3 players and they were rolling a dice, and if they had a 4, if with 2 of them got a 4 and not 3, that was what I wanted, and that's what I calculated. But what if getting 3 4s was also okay? This is what it would look like. I would have 3 situations, one more situation, this one here, that before was not okay and now it is. So there's a slight change, a small change in what it looks like, what the result that I will get. Now, one simple way to calculate this is to simply write it the following way. The probability that I get for more than 2 times is the probability that I get it 2 times plus the probability that I get it 3 times, right? I can't get it 4 because I'm only throwing the dice 3 times. So I just add those 2 together and I'm going to be getting the same answer. But this might be also quite a lot of work. I do recommend this technique if you don't remember how to use cumulative probability, but taking this approach might imply a lot of work. Think about this one, that it's bigger than 1. Well, it might be a probability that I get 1 4, that I get 2 4s, that I get 3 4s, etc. That might mean a lot of work. So often we're going to be using the calculator to calculate this sort of situations. We're going to be using the calculator for cumulative probability. But keep in mind that if at some point, and maybe you're watching this video because you're thinking, oh my god, binomial distribution, I don't remember what that was about. Like I used to know how to do it, but I don't remember anymore. Keep in mind that binomial distribution cumulative problems can almost always be solved relatively easily just by using binomcdf and doing this sort of thing. So it's a good hint, just do this sort of thing. And if you have this one here, keep in mind, well, this is just going to be 1 minus the probability that I get 0 4s. Okay, let's take a look at how do I do it with the calculator. Very simply, it's pretty much the same thing. I accessed binomcdf, well, just underneath I have binomcdf. Binomcdf is for specific probability for a specific value that happens 3 times, 4 times, etc. And binomcdf is going to be for, and I'm going to say it now, it's going to be for at most a specific number of times, at most 3 times, at most 7 times, at most 8 times. Always remember this, it's always at most the number of times that you're going to put into the calculator. So in binomcdf, remember I'm putting number of cases, probability of success, and exact number of successful trials that I want. For example, I'm rolling the dice 3 times, 1/6 is the probability that I get a 4, and I'm going to put that I need exactly 2 4s, and then I get my result. In binomcdf, what you write is, again, number of cases, probability of success, same stuff, but in the R, what you're going to write is how many cases can be successful at most. So keep in mind that that's going to be quite tricky. I can't change it in any way so that I get at least. No, it's always going to be at most, and I'm going to have to do some thinking with that, which we're going to talk about in a minute. Be very careful with not making the mistake of putting a value that actually means at least. Always change it. We're going to see that in the example in a minute. So here's an example. Somebody is driving an exam and they know that there are 40 multiple choice questions. 4 possible answers are offered, okay? And he has 36 correct answers or more to pass the exam. This, by the way, is what the theoretical driving exam in Spain used to be like. So suppose that he answers all the question randomly. What are the chances that he passes? He decides not to study, he just goes ahead and randomly answers questions. What are the probability? What is the probability? So I was thinking, well, what are the chances? Let's calculate it. Well, this is the right condition for a binomial distribution. So either you get the right answer, you get the wrong answer. The probability of getting it right or wrong is 1/4. And they're independent, right? The fact that I have the first question right doesn't mean that the second question is more likely to be right or wrong. Great. So here's going to be my variables, my n, my p, and my r. Okay, I need 36 right answers. So I need probability that it's bigger than 36, bigger or equal than 36. So what we need to calculate, like what I'm getting here is probability of getting at least 36 correct. But what I need is actually what I'm going to be able to, what I can type in the calculators at most. So realize that the probability of getting at least 36 answers correct is the same as probability of getting at most 4 answers incorrect. Okay, so now I can type this in the calculator in the following way. And realize that now the probability changes. I'm not putting 1/4 now. I'm getting 0.75. I'm putting 3/4 because that's the probability that I get it wrong. So what I'm writing here is, hey, I'm going to take this test. 40 questions. 40 times I'm going to answer a question. The probability that I get it wrong is 0.75. And I can get at most 4 wrong. And I can calculate, and this is the answer. Now, the important thing here, what I need you to really focus on, the difficulty of the binomial distribution, is making this switch. Making the switch from at least X number of things right to at most. Be very careful with it. Read it to yourself in your head. Make sure it makes sense. And also, look at the answer. Make sure the answer also makes sense. You have to think, right? To get this exam right, straight off the bat, just answering randomly, must be kind of difficult, right? It can't be that easy. So, of course, the probability has to be very low. And indeed, it is really low. Just how low? This low. That's the probability of passing just out of luck. Thank you very much for watching. That's it for the binomial distribution. Now let's practice a lot, do a lot of exercise, and we can move on. Thank you for watching. Goodbye.